Hello, welcome to the third session of our option pricing using binomial trees course. In this session, we will work with what I call the efficient method of building a binomial tree in Excel. In our previous sessions, we built the trees using conventional approaches. You can see the sheet here. This is the sheet that we prepared. I called it the old school sheet because we went through first the intuition, then a one-step tree, then a two-step tree, and we looked at the amount of effort it would take us to calculate a five-step tree. In the efficient school, we'll start off first with a five-step tree, and then we'll extend that tree to 50 steps. In addition to extending it to 50 steps, we'll also see how easy would it be for us to use that tree to price a call option, a put option, a European call option, a European put option, an American call option, and an American put option. And then we'll take one of those trees and extend it to 50 steps, and hopefully as you will see, we will do that extension from 5 to 50 in just under a few minutes. As I mentioned earlier in my PowerPoint presentation, that the approach that we're going to work with is an approach that I had first seen at work at use by Mark Broadie, the professor who teaches a course called Security Pricing at Columbia University. I call it the Broadie method or the efficient method because it saves an enormous amount of time compared to the conventional techniques that we've seen so far for building binomial trees. So the primary difference between the efficient method and the old school method is here. When you look at the old school method, what the old school method does is that it requires you to build a tree step by step. It requires you to update the formulas step by step, and after a while this gets to be very, very tedious. So if you already have the payoff function here, what Mark does is that he simply flips the tree. He flips the tree from here all the way till here. So rather than starting off here and then going step by step in this direction, you actually start off with the final payoffs. And once you have the final payoffs, rather than going back in this direction, you actually go back in this direction. What this does is that from a calculation, computation, and presentation point of view, it makes your overall job of building a tree a lot more easier. So let's take a look. We start off by building a grid. So we start off with, let's say if you're building a five-step tree, so I'm saying 5, 4, 3, and I'm just going to extend this all the way down to 0. So 5, 4, 3, 2, 1, 0. That's my 5 steps. And then here, let me build this. I'm going to say 5, 4, and I'm going to take it all the way down from plus 5 all the way down to minus 5. There you go, and we have 0 in the center. And I'm going to mark these rows. I call them my 0, 0 rows. So let's mark these rows. There we go. Let's mark this row 0, 0, and let's mark this row 0, 0. There we go. Okay, that's too bright. That's just too bright. Let's just switch that to a more likely natural color. There we go. So now what are we going to do? Start at this point. This point is your spot price. So we're saying at point 0, my price, the spot price for the underlying security is 0. What is this spot price worth one step up? It's simply, if you remember, this is U, right? So you simply take this number, which is the spot price, and you multiply it by your up move, which is 1.11895. And let's lock this. There we go. Now the only problem is that in the up move here, we've said our number of steps is 2. So I need to increase the number of steps to 5. So if I increase the number of steps to 5, this number changes from 1111 to 1.069. And you can see the accumulation factor also changes from here. This, by the way, is the same sheet. These are the same cells that we'd used in the old school calculation. If you go all the way back here, all I've done is I've taken these from here and I've copied them on this sheet. The calculations, the formulas, the numbers, are exactly the same that we used earlier, except now rather than using 2 steps, we're using 5 steps. So if this is the case, and if I've locked it, all I need to do to find out what the tree would be up at the 5th node is scroll it up and down. Similarly, for the down move part, all I need to do is start at 100 into the down move here, lock it, and then control it. So these 5 cells from 0 to 5 and 0 to minus 5 actually correspond to the same cells that you see here. If you were to look at, if you were to do a manual count, this is 5, 4, 3, 2, 1, 0, yes, and then minus 1, minus 2, minus 3, minus 4, and minus 5. Now you can see that every alternate cell does not get used. This cell, this cell, this cell, this cell, this cell. These cells do not get used. I think that's a bad idea. There we go. So these cells do not get used, right? And these cells get used. So at the final payoff level, 5, 3, 5, 3, 1, minus 1, minus 3, and minus 5 get used. At the next level here, 4, 2, 0, minus 2, minus 4 get used, and so on and so forth. So what we've done is, we said rather than calculating all of these numbers in one go here, we'll simply calculate a grid. And this grid is built with one specific point of view, with one specific objective. And that objective is to make calculation, to make building the tree as easy and useful as possible. I need to create a space here. So let me go out and do this. There you go. So I've now done this. Now the question is, what's the payoff? The payoff at this node at 139.85 is simply max of ST. What is ST? ST is 139.85 minus X. What is X? X is the strike, which is 100. You lock in the strike, comma 0. That's the payoff function for a call option at this node when the underlying is trading at this value. If you cut and paste and copy this, you now have your payoff profiles from node 0 all the way down to node 5, and from node 0 all the way down to node 0 minus 5. Okay. So far so good. Now for a next step, we're saying we need to move this also by one step. But for a next step, what we're saying is, and if I've done this, then I need to remove this color, no fill, and put it here with yes fill. Yes fill. There you go. Okay. So now what I have to do is, I'm saying, okay, at node 5, what is node 5? Node 5 is this value, this value, this value, sorry, this value, this value, this value, and this value. What is this worth? This is worth exactly what the payoff is worth. Because remember, this is time 5, this is maturity. So we simply copy these cells. Okay. So now I have node 5. Now, what is the value of the node at this point in time? So at time step 4, what is this node worth? This node is worth, if you remember the formula, this node is worth PV factor. Where is the PV factor? PV factor for one time step. So that's PV factor for one time step. F4, lock it, into the probability of the up move, which is here. There you go. No, that's up move. The probability of move is here. F4, lock it, into the payoff of the up move here. Because at this point in time, the up move is here. At this point in time, the down move is here. Right? So this plus, and don't worry about the fact that the cell is blank, plus the probability for down move, which is here. Again, lock it, F7, into the probability for down move here. Okay, you don't need to lock it because you're going to cut and paste and copy that formula. There we go. Okay. And you save it. So you're saying, well, the payoff at this point in time is actually, if I trace it, is this cell into the PV factor into the probabilities. Okay. Now if I were to copy and paste this across the board from here all the way down to here, and then if I were to control insert, copy it all the way down to here. There we go. Alright, so now what have you done? Now what you've done is, you've actually build a 5-step tree. And what's the answer? What's the premium? What's the actual value that you want to work with? The premium that you want to work with is 11.79. And this 11.79 is the value of a call option at time 0 when the underlying is at 100, the strike is at 100, the volatility is at 15, the time to maturity is 1 year, the risk-free interest rate is 10%, and you're looking at a 5-step tree. And how does this work? If you were to trace this out, and this is where it gets interesting, where does this come from? This comes from, sorry, trace precedence. This comes from here, from these two cells. So if you come to this cell and press trace precedent, where does this come from? This comes from here. Press this cell, it comes from here. Press this cell, comes from here. Press this cell, press this cell, press this cell, comes from here. So you can see, what you can see is, despite the fact that I've copied the formula across the board, as far as the value of the option is concerned, this value of the option ignores all the excess cells. So you don't have to trim it, you don't have to clean the tree. Even if you were to remove these values, you will find that the value is not going to change by much. If I were to repeat this calculation here, at this point in time, you can now see that the same approach works here. And what you're really doing is you're actually following the tree through. You can see the path, you can see the shapes. All I need to do is come here and click this button to connect these two grids. Click this button to connect these two grids. Click this button to connect these two grids, and so on and so forth. Yeah, I think you get the picture. And if you look at the shape of the tree that's forming, the shape of the tree is exactly the shape of the tree that you see here. The only difference, the primary difference by using this approach and this method is that it is very, very easy to build, mainly because all you need to focus on is getting this formula right. Once you get this formula right, all you need to do is cut and paste, copy it, paste it across the grid, and everything else will take care of it by itself. So you get the initial list of values from both the maximum value up and the maximum value down, your payoffs, the range of returns, and you focus on the 0, 0 cell, which includes the premium. And let's call this efficient school. Let's label this efficient school 1. So now I want to save this. I'm going to simply use move and copy in Excel, move to end, create a copy, and work on efficient school 2. What is efficient school 2? What you've just done is the value of a call option. What do you need to do to switch it, to change it so that it becomes a put option? Think about this for a second. This is your payoff profile. This is your ST. And that's okay. How long do you think it will take you to convert this sheet so that rather than looking at the value of a call, you actually look at the value of a put? And let's call it our premium. Our premium is simply 0, 0, which is 11.79. So if I now need to extend this sheet so that I can calculate the value of a put option, all I need to do is update the payoff function. Everything else will remain the same. Because if you go back to this grid, if you go back to our first old school method, these calculations only care about the payoff. As long as the payoff is calculated accurately, the tree will also work accurately. What we've done in old school 2 is all you're going to do is update the payoff function. So the payoff function for a put option is simply, so for a call option it's max st minus x comma 0. For a put option it's max x, x being the strike, x minus st, st being the spot price comma 0. If I flip it, so if I say, let me put this, max of x, where is x? X is the strike, there you go. Lock it, F4 minus st, so this number, comma 0, bracket open, bracket close. And if I drag and drop it, when I let go of the mouse on my side and these cells get updated, you will see that this grid here will also change. So presto, there we go. So all I did was I updated this, and you can see that the grid got updated accurately because the grid itself, each of these values is linked directly to these. As long as you update the payoff, the calculation, the engine that is required to calculate the value of the premium at 0, 0 works by itself. So the premium changes for old school 1, sorry, efficient school 1, the premium is 11.79 here, and for 2 it's 2.27, and that's round about it. So what we've done is we've built a binomial tree. We've built a binomial tree using Excel, and we've built in such a fashion that we can use it to price the value of a call option, as well as value of a put option. If we have these two values, it will take a simple extension to go out and calculate the value of an American call and the value of an American put. I think this is a question that I want you to think about. I want you to spend a couple of minutes thinking about how are you going to extend this sheet. This is a sheet for valuing a put option. Efficient School 1 is a sheet that is a sheet for valuing a call option. And this is a European call, this is a European put. I'm now asking, can you calculate, can you evaluate, can you price, rather than a European call and put, can you price and value an American call and put? How would you change the sheet? What do you need to change in this sheet for you to be able to price an American option? Think about this for a few seconds. When we come back for our next session, this is the question that we'll try and answer. Thank you very much for your time. This is Jawad Ahmed Fareed signing off for financetrainingcourse.com.